Inverse circular functions. Let's review what inverse functions are. The domain of f is the range of f inverse, and the range of f is the domain of f inverse. By that, what we mean is, if we have the points 3, 7, 1, 6, and 0, 5 in the function, then its inverse would have the points 7, 3, 6, 1, and 5, 0. The domain and the range just flip. If we were to look at the graphs of the two functions, the graph of f and the graph of f inverse, then they would be reflections of each other across the line y equals x. To evaluate the following trig functions, we just need to find what the values of these trig functions are for these angles. The sine of 90 degrees is 1. The cosine of 2 pi is also 1. And the value of tangent of 51 degrees, we would need to use our calculator in degree mode, and we would find that it's approximately 1.234897157, and it would keep going. It's an irrational number. So we've learned that when we evaluate a trig function, we're given the angle and we need to find the real number value of the answer for the answer. So the inverse of a trig function would be if we're given the real number and we have to find what the angle is. The symbol for finding this inverse would be either this, a -1, and it would look like this in the trig function. And this would be read as sine inverse of x. Or we might see this arc, and it would be written like this in a trig function. And we read it as the arc sine of x. But they both mean the same thing. If we're asked to find sine inverse, or if we're asked to find the arc sine of x, it means the same thing. Remember that if we see that little -1, if we see this symbol here, that does not mean that it's an exponent. This just means that it's the inverse of the function. So, as a reminder, these are what the trig functions look like. And if you'll notice, they are functions. Remember that a function passes a vertical line test. If we were to take a vertical line and pass it across the graph, it wouldn't touch the line in more than one point at a time. And these would pass that vertical line test. But if we're going to take the inverse of the trig functions, that means that we have to reverse the x and the y axis. So if we were to flip the x and the y axis, it wouldn't pass the vertical line test. So we have to restrict those values in order to make it be a function. So these are what the principal values look like for our different trig functions. The values are restricted. Sine is restricted to just between -pi/2 and pi/2. Cosine is between 0 and pi. And tangent is the same as sine between -pi/2 and pi/2. Cosecant goes between -pi/2 and 0 and +pi/2. Secant is between 0 and pi/2 and pi/2 and pi. And then cotangent is between 0 and pi. So this is a chart of the values for our inverse functions. We'll be dealing mostly with sine, cosine, and tangent. If you'll notice, the domain for sine and cosine are the same. The domain is between -1 and +1. And that's because we're on the unit circle. And so our x values would be between -1 and +1. The range or the interval of sine is between negative pi over 2 and positive pi over 2, but for cosine it's between 0 and pi. So in sine we're in the first and fourth quadrants, and in cosine we're in the first and second quadrants. Tangent has a domain that's from negative to positive infinity, and its interval is the same as sine, from negative pi over 2 to positive pi over 2, and it's in quadrants 1 and 4. Now, when we're dealing with these inverse functions, if we see something like this, y is equal to sine inverse of 1/2, we're looking for, or we can say it this way, we can say what the angle whose sine is 1/2 is what, because we're looking for an angle when we have the inverse. So we're saying what angle has a sine of 1/2? And we know that that would be 30 degrees. Another thing that we need to be aware of in this book, if you see a y, so y is equal to sine inverse of x, then that's going to be, we're going to be using radians for our answers. And if we see theta is equal to sine inverse of x, we're going to be using degrees for our answers. Alright, this says use a calculator to approximate each value in decimal degrees and round to the nearest 10,000th. Okay, so if we were to use a calculator, if you'll notice on your calculator, the same button has cosine and cosine inverse. So you just have to press that button on your calculator twice to get to cosine inverse. And since this has got theta in front, we are going to be in decimal degrees. It also says it here in the directions, decimal degrees. So make sure that your mode is set to degrees. Make sure it's in degree mode and not radian mode. So as long as your calculator is in degree mode and you hit your cosine button twice and then put in this value negative 0.13348816, then you should get your answer, which should be 97.6712, and that's rounded to the nearest 10,000ths. Okay, so if we try another one, again, keep your calculator in degree mode. Make sure that you hit sine twice, because arc sine is the same as sine inverse, so we're finding the angle whose sine is 0.779000016. So put that in your calculator and rounded to the nearest 10,000ths. This should be your answer, 51.1691. Now for cosecant inverse, we don't have a button for cosecant or cosecant inverse, but we know that cosecant is the reciprocal of sine. So this is how you would put it into your calculator. You would hit the sine inverse button, and then we would take the reciprocal of that value. So in our calculator, we would put in the fraction 1 over 1.9422833. And when we put that in, we should get this for our answer, 30.9880. Alright, this says use a calculator to approximate each real number value. Okay, that statement plus the fact that it's y and not theta tells us that we need to change our calculator to radians and not degrees. And also we know that arctangent means the same thing as tangent inverse. So we would first make sure that our calculator is in radians and then press the tangent button twice to get to tangent inverse. and put in 1 point, and there's 1, 2, 3, 4, 5, 6, 7, 8 ones. And so if we put that in our calculator, we get that y equals 0.8380 when we round it to the nearest 10,000th. Okay, secant, again, we don't have a button for secant, but we know that secant is the reciprocal for cosine. So this is how we would put it in our calculator. We would put in cosine inverse of, and we would take the reciprocal of this value and put that in our calculator. And you should get 2.4605 as your answer. And that's the real number value. All right, find the degree measure of theta if it exists without using a calculator. So these are values that we should be familiar with. For A, it says theta is equal to the arctangent of 1. So we're looking for the angle whose tangent is 1. And remember, it's restricted. Tangent is restricted between, since we're using theta, that means that we're using degrees. And again, it says it up here. So we're talking about degrees. So tangent is going to be restricted between negative 90 degrees and positive 90 degrees. So tangent would be 1 at 45 degrees. All right, sine has the same restrictions. It's just the values between negative 90 and positive 90. So the angle whose sine is a positive 1/2 between those values would be 30 degrees. Okay, the angle whose cosine, or the arc cosine, of square root of 2 over 2, we know that that would be 45 degrees. Okay, so for the secant secant inverse of 2, that would be the same thing as cosine inverse of 1/2. Okay, the angle whose cosine is 1/2, and cosine is restricted to values between 0 and 180 degrees. So we're saying, where is cosine 1/2 between 0 and 180 degrees? And it would be 60 degrees. For the arc secant of 2 square root of 3 over 3, this would be the same as cosine, or arc cosine. Let's write it like that. Of, if I were to flip this value, it would be square root of 3 over 2. So I want to know that angle whose cosine is square root of 3 over 2 between 0 and 180 degrees, and that would be 30 degrees. Okay, so for arc sine of negative 1/2. So remember, we just did the sine inverse of positive 1/2, and that was 30 degrees. The angle whose sine is negative 1/2, we're dealing with the restrictions between negative 90 and positive 90. So in quadrant 4, we don't say we don't say like 315 degrees, 300 degrees. We don't say those degrees. We do negative 45 degrees, negative 30 degrees, negative 60 degrees, like that. So the angle whose sine is negative 1/2 in that fourth quadrant would be negative 30 degrees. For the cotangent of negative 1, that would be the tangent inverse or cotangent inverse of negative 1 would be tangent inverse of negative 1, because if we take the reciprocal of negative 1, we get negative 1. Now, dealing with cotangent and tangent, there's a little something that we need to know. Well, cotangent is found between 0 and pi, and tangent is between negative pi over 2 and pi over 2. Or if we're talking about degrees, cotangent is between 0 and 180 degrees, and tangent is between negative 90 and positive 90. So if we have a value of cotangent that's in that second quadrant, so if you picture the unit circle, and the value of cotangent is somewhere between 0 and 180 degrees, and the value of tangent has to be between positive 90 and negative 90. Well, if the value of cotangent is somewhere here in that second quadrant, we can't equate it to tangent unless we add 180 degrees to it. So whatever the value of cotangent is, if it's here in the second quadrant, we're going to add 180 degrees to it to make it be equivalent to tangent where it's defined, because tangent is not defined, it's not a function in the second quadrant. So you just need to remember that anytime we have cotangent inverse of x, then that would be tangent inverse of 1 over x. So it's the same if x is greater than 0. But we have to do 180 plus tangent inverse of 1 over x if x is less than 0. So since this is cotangent inverse of negative 1, since that's less than 0, then whatever our value is, we're going to have to add 180 degrees to it to get the tangent inverse of negative 1. So we know that cotangent, or that tangent inverse of negative 1 is a negative 45 degrees. So the angle whose tangent is negative 1 is negative 45 degrees. And to get the cotangent, we're going to add 180 degrees to it. So that means cotangent inverse of negative 1 would be 135 degrees. For h, the cosine of 0 degrees, or the angle whose cosine is 0 degrees, would be 90 degrees. The angle whose sine is 2. Okay, so if we think back to our unit circle, remember that sine is y over r. Okay, so if my sine is 2, this would be 2 over 1, so that means my y value would be 1, and r, which is my radius, or my, in the Pythagorean theorem, that would be my hypotenuse of my triangle. My r, the hypotenuse of my triangle, would be 1. Well, the hypotenuse can't be less than, the hypotenuse has to be the longest side. So since here, my hypotenuse is less than what y is, that's not possible. So this does not exist. And we said that the range of sine is between -1 and +1. Well, again, this is greater than -1, or +1 is greater than +1. So that's another reason it cannot exist. All right, find the exact value of each number y if it exists without using a calculator. So again, the exact value plus the fact that we have y's in front is telling us that we're going to be using radian measures instead of degree measures. And we're not supposed to be using a calculator. So these are ones that we should know. So the angle whose sine is 0 would be 0 radians. The angle whose cosine or cosine inverse of -1 would be pi. The arctangent, or the angle whose tangent is 0, would be 0. The cotangent inverse of -1, this would be the same thing as tangent inverse of -1. Again, if we take the reciprocal of -1, we still get -1. Well, we know that the tangent inverse of -1 is -pi/4. Well, remember, to find the cotangent, we're going to have to add 180 degrees, or in this case, we're dealing with radians, so we're going to have to add a pi. So that would give us 3pi/4 would be cotangent inverse of -1. So cotangent and tangent, that's the only one that we have to modify when we're trying to find its values. All right, for arc cosecant, cosecant is the reciprocal of sine. So this would be the same as the arc sine of -1/2. Well, the arc sine of -1/2 is -pi/6. All right, and then secant is the reciprocal of cosine. So this would be the same as cosine inverse of 1 over the square root of 2, which when I rationalize that would be the square root of 2 over 2. And we know that the cosine of square root of 2 over 2 is pi/4. All right, the cosine inverse of negative square root of 2 over 2, we know that that's going to be in the second quadrant. So that would be 3pi/4. The sine inverse of square root of 3. Well, the square root of 3, if we were to put that in our calculator, we would get 1.7320, and it keeps going. So it's greater than 1. So just like before when we were trying to find the sine inverse of 2, it's greater than 1. That can't work, so this does not exist. Okay, for the arc cotangent of negative square root of 3, that would be the same as the arc tangent of negative square root of 3 over 3, or it's 1 over the square root of 3, and when we rationalize it, that would become the square root of 3 over 3. And we know that the angle whose tangent is negative square root of 3 over 3 is -pi/6. Well, again, to get to cotangent, we're going to have to add pi. So if I add 1 pi to -pi/6, that would give me a positive 5pi/6. All right, this is to evaluate each expression without using a calculator. All right, so if you'll remember, when we're finding the inverse, we're saying what angle has this value. So we're saying the angle whose sine is 1/2. Well, we know that the angle whose sine is 1/2 is 30 degrees. But then the sine of 30 degrees is 1/2. So basically, anytime the inverse and the trig function on the outside are the same, it basically cancels out and it's just going to be whatever that value is. So secant of secant inverse of square root of 2 would just be square root of 2. Now when they're different, you have to go through the steps. Okay, so this says the tangent of sine inverse of square root of 3 over 2. So we got to work with the inside first. And the sine inverse of square root of 3 over 2 would be 60 degrees. So this is 60 degrees. So now we want to know what the tangent of 60 degrees is. Well, the tangent of 60 degrees is the square root of 3. Tangent of arc cosine of 3/4. Okay, so now this is not a value that we are used to. So what we're going to have to do is we're going to have to use the Pythagorean theorem to figure this one out. Okay, so since the value inside for cosine is 3 over 4, we know that cosine is the same thing as x over r, if you'll remember back to when we were dealing with triangles. Okay, so if cosine is x over r, that means that my x value is 3 and my r is 4. Well, to find tangent is y over x. So we still need to find out what our y is. Okay, so if we do the Pythagorean theorem to find this out, and I see that we have a 3 and a 4, but don't get that confused and think that this is a 3, 4, 5 triangle, because in a 3, 4, 5 triangle, the radius is 5. Well, in this case, it's 4. So we're going to have to use the Pythagorean theorem to figure this out. So let's plug this into the Pythagorean theorem. Okay, so in the Pythagorean theorem, we have x squared plus y squared equals r squared. So my x is 3, so that would be 3 squared plus y squared equals, my r is 4, so that's 4 squared. So that would be 9 plus y squared equals 16. Subtract 9, and I get y squared equals 7, and then I take the square root of both sides, so y equals the square root of 7. Okay, so then that means that the tangent would be y over x, so it would be the square root of 7 over 3. And that would be our answer. Okay, we're going to have to do something similar for E. Tangent inverse of 3 over 2. Okay, so we know that the tangent inverse, or the tangent is y over x. So that means that my y value is 3. My x value is 2. And for sine, it would be y over r. So we need r. So again, we're going to do the Pythagorean theorem. X squared plus y squared equals r squared. So that's 4 plus 9 equals r squared, which is 13. And when we take the square root, we get that r is the square root of 13. So sine would be y over r, so that's 3 over the square root of 13, which rationalizes to 3 square root of 13 over 3. Okay, and for our last one, we have cosine of tangent inverse of -2. Okay, so for the tangent is y over r. Okay, so this is understood to be over 1. So that means that my y is negative 2. I think I said that tangent is y over r. Tangent is y over x. Okay, so the y is negative 2. The x is 1. And cosine would be x over r, so we need to find r. Okay, so again, if I do the Pythagorean theorem, x squared plus y squared equals r squared. So that would be 1 plus 4 equals r squared. And that's 5. Take the square root. So r is the square root of 5. So that means cosine would be the square root, cosine would be 1 over the square root of 5, and that would rationalize to become the square root of 5 over 5. And that's our answer.